So good evening. Today we are at the sixth day of our online lecture series uh, on emerging technology, where we will hear about the 5G and advanced network from the two experienced speakers from the industry, Abhijit Pal and Paromita Ghosh. At the beginning of the discussion, I would like to introduce them. Abhijit Pal is a senior business leader with over 25 years of experience in technology consulting, digital strategy, and enterprise transformation across India and international markets. He currently serves as the executive director and the board member at Alphaxine Solution Private Limited, where he provides the strategic and the operational leadership to drive the innovation and growth. His expertise spans technology and digital strategy, enterprise applications and integrations, analytics and artificial intelligence and emerging technologies, with sectoral experience across government, retail, FMCG, healthcare, education, telecommunications, and manufacturing. Mr. Pearl is a honorary advisor to several prestigious bodies, including the IT Committee of the Bengal Chamber of Commerce and Industries, Association IT Council of India, and AI Center of Excellence, and has also advised the IT and Electronics Department, Government of West Bengal, an alumnus of the Jadavpur University in Electronics and Instrumentation Engineering. He is a technology experienced mentor and award-winning leader who regularly engages with the premier institutions and the global forums. Paromita Ghosh is an accomplished industry professional with over 22 years of experience in the telecommunication sector and currently serves as a general manager, business management and analytics at Ericsson. She has a strong track record in large-scale service delivery, business strategy, transformation initiative, capacity development, and the operational excellence with the focus of the sustainable business growth. With deep experience in the 5G cloud technologies, Azure, AWS, and telecom innovation, she has led complex global programs, improved delivery governance, and enhanced the organizational performance. Her prior roles at IBM and Wipro have provided her with the extensive global exposures and the cross-industry insights. A strong advocate for the diversity, inclusion, and the innovation, Mrs. Ghosh brings a strategic and forward-looking approach to leadership and organizational transformation. I request all of you, before starting the session, just please turn off your microphone and the camera during this discussion. And like other lecture series, there will be a question answer session at the end of the discussion. So if you have a question, then raise your hand and I will select accordingly. Now I would like to request the speaker to start the discussion, please.
Thank you, Pritimoy. And I think before we start, we are definitely going to take help of some slides and we'll also voice over. But I think while we don't have time for introduction of all of you individually, but it would be good to have an understanding, Pritimoy, of the group or the cohort we have today here in terms of the background and their years of experience, if any, so that while we have a set of slides, but we can definitely tailor or modulate our discussions accordingly. Do we have any broad level overview of the participants, Pritimoy?
Yeah, most of them from actually the faculty members and also the students of our affiliated colleges. You know that under our university, more or less 175 colleges are there. So most of them are the students, engineering students, and faculty members also there.
No, so which stream?
Actually, I am not able to identify in which stream because during registration, we actually emphasize that they are coming from the ECE or computer science and computer science.
Okay. So maybe, as we do in corporate programs also to make it most effective. Maybe one of you can just volunteer on behalf of the entire cohort and tell us a little about what you are expecting from this course. While we have a set of topics to be covered, but it is also important to understand your expectations before we start. Maybe one of you can volunteer and speak maybe 2 minutes about it.
Any
So
faculty
I
member?
request, I request someone. Actually, I request just raise your hand and tell what the speaker actually want to know from you. Please.
Okay, in absence of an answer, I would assume that people are expecting what is there in the course curriculum, and we'll try to cover it as much as possible. We assume that there is no specific expectation from anyone, and we go ahead that way. Pritimoy, right? Is that a fair understanding, Pritimoy?
Yes.
Okay. Paromita, slides, if you can please
Okay.
share.
Pritima, you need to make me host so that I can share the slide.
You can share. I give it there. You can share.
Yeah. Let me know once it is visible.
It is for me. For others, I don't know.
Okay.
Yeah, it is
This
visible.
is and full screen
Yeah.
mode, right?
Yes.
Okay.
Okay. Okay, I
So
think the first slides talks about us, and Pritimoy has already spent some good amount of time in introducing us, so we'll leave that. This is roughly what we are trying to cover today. While these are the broad topics, but there are quite a few slides and which talks about the theoretical aspects, the history, the technology, a little bit of technology nitty-gritties, some case studies. There's an activity for all of you. I hope you will all not go, fall asleep or, get bored, and will participate in that activity. It's a group activity for all of us. And then we will talk a little about the emerging technology areas, some of the industry case studies, which and how the trends are shaping up in telecom in India and across the globe. So if you are an engineer coming out of a college, what kind of work you can expect to do. And obviously, we'll have a short Q&A session at the end. We will try to cover all the Q&A at the end of the session. We'll have a separate slot for that. We will not try to get interrupted in between, so that you would understand that there is a flow that we'll try to maintain. If we lose that flow, then it becomes a little difficult. So we'll request all of you to kind of keep your questions till the end of the session, or else if you want to, if you tend to forget them, put it in the chat. We'll try to go through the chat at the end of the session. Why connectivity matters, and while I said questions and answers towards the end of the session, we can make it a little interactive. When I say interactive, on certain slides, there will be some questions from our side, where we would expect some of you to volunteer and give your thoughts. It is not required that you will be 100% correct. And we are also not in a classroom session that or a quiz that will give you prizes for that. But just to make it interactive and interesting for all of us, we will try to make it a little interactive. Why does connectivity, or why connectivity matters? And we will talk mostly from a India perspective in whatever conversations we will be doing in the next 2.5 hours. So can you tell me, in the last 20, 25 years, what are the two most promising disruptions in the technology industry that we have ever confronted? Any guess, wild guesses? Any thoughts? What are the two most promising disruptions that have happened across the globe in the last 20, 25 years? Okay, cheap internet. What else? Rahul? At least somebody responded. Anyone else? Any thoughts? We all are engineers here, so we should have a wild guess at least. Can smartphone be termed as a disruption? Again, Rahul, yes. Okay. Anyone else? I think Rahul is the only person who is attending, Pritimoy.
I am not sure.
We have a second person who is attending, Deepak.
Yes.
See, we'll have to also keep us excited, otherwise we will fall asleep. Okay, why is a smartphone a disruption? Cloud too, okay. Okay, let's focus on smartphone. Let's focus on internet. Why is smartphone a disruption? While we are using it on our day-to-day life to the extent possible, even children of 3 years of age or even 2 years of age, till people who are 75, 80, to whatever extent they can use it, or even more, they're all glued to their smartphones. So how has smartphone become a disruption? Let us take some common examples. We used to go for shopping in a mall, at least, or if you all of you are from Kolkata, let's say from Gorihat market. Even I remember my childhood days, there was no concept of shopping through internet or through a mobile phone. But now, at least, there's a fair amount of people who would like to go to a particular website or an app, browse through all the items they want to buy, and they would probably order it on an Amazon or a Flipkart or any of the larger e-commerce apps or portals that are available there. We used to run through the roads to catch a yellow cab. And I am assuming all of you are from Kolkata. Okay. Now I'm sure there is only 2 persons attending the call.
Yeah, no, Rahul Prakash maybe volunteer on behalf of all.
No, if all of you are from Kolkata, there is no answer, then I think there's a real problem somewhere. Okay,
The
we
number
have
is
the third
increasing
person.
now.
Okay.
Yes.
Do we look so bad? We can switch off the cameras then. Okay, so I don't think it can be interactive, Pritimoy. So we'll just go through the slides. With this, numerous activities that we do in our day-to-day life, once those activities can be done through a single device that we carry on with us on an every time basis. And the turnaround time for any activity through that device drastically falls. It helps in our day-to-day life. It helps in business to run. And it is a lever for an end-to-end digital transformation. It helps us to collaborate. LinkedIn, Facebooks of the world, people are connected all the time to, and there are those WhatsApp or all kinds of chats that are available, and also social media, which has connected all of us in different parts of the world, sharing knowledge, sharing thoughts, sharing feelings, emotions, and with all these, and with the government also taking measures to bring in initiatives like UPI, the payments unified payment interface, the public infrastructure that is there. With all these, with the public inclusion, the government intervention, and the private companies coming in together, digital transformation in India has taken a leap in the last 15 years. And over the last 5 years, with the emergence of artificial intelligence, as we speak, you would all know that we are having the India AI program event in New Delhi now. And there are a lot of things being discussed. Intelligent automation is going to a next level as we speak here today. And all these are part of the larger umbrella of digital transformation, as we call it. But for all of these, the two things that matter the most, or the three things that matter the most, are the infrastructure. I think somebody pointed out that cloud is a disruption. I think yes, in a way, cloud can be termed as a disruption because it is changing the way we have thought about technology infrastructure. It has been there for quite some time now, because when we initially thought about digital as a subject, it all started with a terminology called SMAC, which is the acronym being Social, Mobile, Analytics, and Cloud. So it started around the late part of the first decade of this century. And then there were a lot of other, advancements that had happened over the years. But cloud obviously has given the infrastructure that is required to take digital transformation to the next level. The second key lever is applications, which is all the applications or the apps or the different kinds of systems that we develop using the platforms, products, tools, technologies on the infrastructure that we have. And third is definitely the connectivity, because unless you have the connectivity as required, however strong the infrastructure is, however strong or relevant to your app is, you won't be able to connect. So from the journey from, up to 5G and probably 6G coming very soon, I think the connectivity is very, very important in the overall scheme of things. So for students, I think if you understand this overall broad landscape, and that is why this, uh, you know, uh, first starting slide is very important. If you are, keen on getting into a career in digital transformation, in whatever sector it is, in whatever function it is, in whatever geography it is very important to understand whether you are getting into research, whether you're getting into startups, industrial roles, or into a pure play technology or a IT development role, including smart city and IoT projects. It is very important to understand that connectivity plays one of the most significant roles in that overall scheme of things. Paromita, next slide, please. If you all are from EC background, or some of you from CAC backgrounds also, electrical background, I think some of you also would know this. And if you are keen on understanding the evolution of mobile networks from 1G to 5G, we are in 5G today. This is a broad diagram which depicts the evolution of mobile networks, and I'm specifically talking about wireless networks. So 1G typically from basic analog voice to 5G. Just go to the last slide, to 5G, where we are talking about ultra fast connectivity in terms of both like voice and data. And all these 2G, 3G, 4G are evolution that has been intermediary between 1G and 5G, where slowly we have moved from analog to digital, digital to a combination of data and voice, and then to high-speed data, and then ultra-fast connectivity. So where we stand today is 5G, in India at least, and which forms the foundation of all kinds of mobile connectivity at a basic level for voice and data. And for IoT and smart cities, I'll come to IoT and smart cities in later slides. And obviously, you would see that that ad from that commercial, TV commercial from Airtel, with that typical music playing at the background, which says that even if you are at the top of, probably a high, mountain pass, or even in the Leh Ladakh region, you will probably get connectivity. So the penetration of 5G into remote areas with high speeds is something that India and the service providers have achieved. While there are complaints, I know as consumers, we all have complaints for all the service providers we are individually using. In fact, as we speak today, I have just lodged a complaint yesterday with my service provider. But at the end of the day, I think with a country of such a high population, deep penetration into rural areas, I've been to, if you all of you are from this part of the country, I've been to very remote areas in the Sundarbans, and I've seen connectivity has penetrated till there. And most importantly, people with mud houses, they are using smartphones, which is a definite triumph of technology today. Technology, and particularly of the telecommunications as a technology today. I think the last point that we are talking about, virtual reality and augmented reality. I don't know how many of you are aware of the term, but even if you are talking about uh, a lot of digital, applications that are being used by individuals, governments, businesses today. Uh, if you think about, and it starts from the mobile apps, it starts from the different larger enterprise applications. It starts from the emerging technologies like artificial intelligence, machine learning, blockchain, virtual reality, augmented reality. All these would need at some point in time or the other a very strong foundation of your network, and that is where 5G is all about. We have stepped into 5G in India around 2020s. We are still there, and we are very close to Paromita being a part of one of the largest telecom giants of the world. She will tell you the journey towards 6G, where we are globally and also in India. But currently, I think we are more or less happy with where we are with 5G. Next slide, please. This is the beginning when we talk about 1980s and analog voice. And I don't know how many of you, I'll just try to use some of the technology terminologies here. AMPS, you see there in the slide. It is known as, I know you would do an easy quick search in Google, but just to give you an idea, it is advanced mobile phone system, and NMT is Nordic mobile telephone. And I think at a basic level, since we are all engineers, I think it was launched mostly in the early 80s, 1980s. And I think it became kind of widely distributed analog standard, started with the continental USA. And on a technology side, it predominantly used FDMA, as you all would know, because you all are from the engineering background. And as far as I remember, it was primarily operating in the 800 megahertz band. And I think at a very high level, 1G, if you look at 1G, both AMPS and NMT, they were analog FM for voice, and they were primarily designed for carrying voice. So there was no concept of data at that point in time. Right, so that's where we started. Next slide, please. Then came the 2G revolution, 1990s. I am not too sure if some of you would have been born by then, but if you were, then you would know the the revolution, how it happened with GSM, which is the Global System for Mobile Communication, TDMA, CDMA, all coming into as technologies coming into picture. And I think at a very broad level, we were talking about FDMA earlier, and now I think it was a combination of, and when we talk about GSM, it was a combination of TDMA and FDMA coming together to manage the user access. So that's the primary difference. And this is where also the concept of SIM cards started coming in, because the SIM cards were usually getting started to be used for storing user information. And at that point in time, the SIM cards were easily transferable from device to device. I remember I was, and this was again at a later point in time when I traveled to US, then there was a concept of locking and unlocking of phones. And a SIM card was particularly connected to a particular service provider and the phone was locked with that SIM card. But when I'm talking about the 2G in the 1990s, there was no concept of locking at that point in time, until unless CDMA slowly came in, which is code division multiple access, which is the broader term. And it the primary difference between GSM and CDMA was that CDMA allowed multiple users to transmit simultaneously over the entire frequency spectrum. So that's the primary difference between GSM and CDMA. Obviously, you all being telecom engineers, you would have probably learned a lot more about TDMA, FDMA, GSM, CDMA in your theoretical classes, but it is very important to understand how this contributed in the journey of the wireless telephony revolution over the last 40-45 years. Next slide, please. Then I think came 3G, and this is where internet was available on your phone. And I think the key term or the key technology that started being used at this point in time was WCDMA, which is wideband code division multiple access, and HSDPA and HSPA are also some of the technologies that were used at in that part of in that time region when we are talking about 2000 to 2010 roughly broadly. And as far as I remember, it uses a 5 megahertz channel bandwidth, most importantly allowing both voice and data services. So this is where the internet revolution that we were facing in our desktop or laptops at that point in time, they slowly started moving into the mobile phones also. And it was very, very essential that apart from the lease line that we used to have, the PSTN lines, the wireless telephony also provided us access to internet seamlessly, while the speed was not so high at that point in time, but definitely it opened the world to internet from your device at your hand, anywhere, anytime access to internet. And this is where the revolution all started. Next slide, please. Then I think when we crossed 2010, you would see 4G/LTE in some of the phones still today. Phones which are not compatible with 5G. Some of us are using older models, which still shows that even if you are in a 5G connectivity provided by a service provider, the effective connectivity that you are getting or the service you are getting is 4G or LTE. And obviously, when you talk about 4G, just hold on. Yeah, LTE, OFDMA, and the throughput. I'll request Paromita to kind of take over here. And the throughput, most importantly, increased substantially to even 100 Mbps. So if you are taking this connectivity from a service provider, they would typically come to you with different packages of 30 Mbps, 50 Mbps, or 100 Mbps. And you would probably see that if you are taking a 100 Mbps line from a a Tata Play or a Jio, then how and even if it is distributed in your home for your personal usage through a router, the kind of speed that you get practically on the ground, how it has changed over time. So we'll get to see that if you're using one of these today. And obviously, today, if you're talking about 5G, it is one single platform providing all kinds of apps, voice, and even streaming of your OTT in your TV or your in your television, or even other utilities that you might be using through your 5G. So I'll hand it over to Paromita to talk about how it moved from 4G LTE to 5G as a technology, and how we as users, we as technologies actually adopted this change, and what are the things that are coming up for us in the next few years. Parvita, over to you.
Thank you, Abhijit. So now that we have gone through from 1G to 4G, now the excitement begins with the new radio coming in. What is now the radio? Radio is the background, or the one which is running. It is not that radio, okay, where we heard music, or where our grandfathers used to heard music. It's the radio which is the infrastructure of a telecom. That's what a radio is, if anyone is a little bit wants to know about it. Now, new radio is what we brings in 5G. What it brings is, it brings performance, and with the software-based architecture, which is the brain of the network. It brings the intelligence and the flexibility. If you know about microservices, so these are coming into picture. Previously, it was a monolithic code that we used to write. Thousands and thousands lines of code were written. Now the software development went to a microservice mode. Small functions which can be independently developed, deployed, tested, and it can be independently used. Then it comes about the API technologies as well, and which uses the HTTP or the REST interfaces. This is coming with a stateless design. That means it is enabling the organizations to scale up. So if it is small, if it is HTTP based, and if it is stateless, then again it can be cloud native as well. So I think few of us are already aware of the cloud. If not all, then the things are becoming cloud native. That means it can be residing in the cloud. The next thing comes is the automation ready. That means if this is something which can be running at that speed, it can be automated as well by various technologies. One of this is the CI/CD pipeline, the continuous integration, continuous deployment pipeline. That means there is a running system for an organization. Developers are still working on it in all the technologies that I just mentioned, in microservice based, in API, stateless designs, and those can be uploaded in a pipeline, which if you think about is as a real pipe. It goes to the customers after passing many of the checks and balances in between. Now let's take a look at the releases at a glance. Release 15 of 5G is the full standard 5G new radio, which is the NR, as I mentioned. Enhanced mobile broadband is there, which is the EMBB. Release 15 also defines the NSA and the SA architecture. Now, what is NSA and SA? NSA is the non-standalone, and SA is standalone. You know, whenever as an employee of an equipment organization, we come to know that these equipments are worth crores of rupees, crores of money, in whichever form, in whichever currency you may say. So the boxes or the infrastructure which was there, or the equipments which were there for 4G, If the customer or if the telecom service provider wants to reuse it, they will be non-standalone implementation. That means some part of 4G is used and some software of 5G is being used to have a middle ground, not a full 4G, not a full 5G. It is called an NSA or non-standalone. And standalone is everything fresh, everything there is nothing of 4G, fresh implementation, and it's called SA 5G. So with all these NSA and SA architectures coming in, that is also in release 15. The other feature of release 15 is massive MIMO. MIMO is multi-in, multi-out. If you see the antennas which are uploaded there in many of our terraces, there will be some boxes which are there. There are various technologies which are there, which can be one in, multi-out, one in, one out kind of thing. So multi-in, multi-out was there in 4G. However, in 5G, it comes as massive multi-in and multi-out. So massive MIMO, as we call, massive MIMO, as we called, is there in this release. And with 4G, we have low latency, but in 5G, we have the beamforming and connectivity first attitude for release, release 15. 5G phase 2 comes with the release 16, which has first, very important, URLLC improvement, which is the ultra reliable low latency. What it does, it has very latency is, if I may explain, it is the difference of time between the action and the response. Okay, very low latency. These are needed for industry reliability. For example, if you see robotic surgeries and all these, and trains, autonomic vehicles, this will need very low latency, right? If there is a car coming in and the other car, which is let's suppose it's an autonomic vehicle, it cannot steer away or move very fast within a fraction of a second. There is no point in such a connectivity. So ultra reliable low latency, URLL, is one of the URLLC is one of the things which are defined in release 16. This also has the private 5G support, the network slicing maturity, and the TSN, which is the time sensitivity network. Let me explain slicing a bit here. Now, when we had analog, we had only one kind of a frequency. When we had data, there is a different kind of a thing. Now, when these are all what user data, there is also a set of data, there is also a set of information, if I may say, which is passing, which is about the user's control. So the user data is there and the control data is there. What does this control data have? Control data has the user information, what kind of package that person is, if that is in low latency, or there is any other priority which is assigned. For example, many of the countries of the world, especially in the Middle East, they have special bandwidth or special slice for people who are there in the emperors and all. Okay, so those people will have different kinds of, because there will be some priority data that needs to be flown there. Also, there can be data which is, as I said, about the trains or autonomic vehicles, which can be moving at very fast. There can be something which can be a little bit slow, but a massive amount of data. For example, video streamings and all. So there are different kinds of data which can be divided into different slices. That's what network slicing is. First, divided into data slice and the control plane. And then with that, divide what the user wants. So these are all with release 16. Now with release 17, there are these NTNs coming. NTN is the non-terrestrial network. It's the satellite integration, which are coming in. Now, if I may say that we had shared some out of office replies which says that, oh, I am in non-network covered zone. that will be very soon going away because the whole terrestrial and the non-terrestrial will be covered. So wherever you go for a vacation, you still will be covered in any kind of a network. Also, then red cap devices are coming in. What is a red cap device? It is the reduced capability device. Any device, if you see, be it antenna, be it core, that means which is processing, be it transport, any kind of a device, it needs power. There are a lot of power which is needed, and the research is going on how we can reduce those power need of these devices. Here you will hear a lot about green devices, green core, green RAN kind of a thing, which it says that we are at almost zero power consumption. So now at this release 17, the focus is on reduced capacity. Also, we have improved positioning accuracy, energy efficiency improvements. That means overall the consumer is going to from the focus perspective, it is moving from just a consumer to enterprise grade. Okay. Next is the release 18. So release 18 is 5G advanced. It bridges 5G with 6G. It adds intelligence, so the AI is coming into the picture, and automation. It unlocks the real enterprise monetization, and by using AI native networks. So this is a new term I'm saying. Cloud native was earlier, now it is AI native networks. So there will be AI implemented within the network, which might change some parameters of the network according to the need. For example, there is a big match going on in Joe Bharati Freedom, if you may say, the Salt Lake Stadium that I stay very near to that. And I am doing this session, right? If there is a big match there, it should not hamper my recording or my internet usage. So those things will be, the AI native network will be intelligent enough to understand that there is a big demand on this particular area. So have more resources there so that the rest of the items are not hampered. Then is the enhanced XR VR, as Abhijit was also mentioning. It is AR VR, we together called as an XR and immersive media. So these will be coming in a bigger form in 6G. However, with this latest release, it is going towards that, so that when we have the non-NSA, which is the non-standalone, so 4G to 5G, it's kind of a low-end 5G. Then we have 5G, which is full-fledged. Then we have advanced 5G, so that it can be transferred to 6G when the time is right. The reduced capacity devices, which is the mass IoT expansion, is also coming in this release, and energy, and I was mentioning about the green RAN, sleep mode, etc. Now, a little bit about the sleep mode. What is sleep mode? Within area, there are trends which says that some of the antennas, if they can be switched off in some time of the day, it can save some power. Instead of somebody going ahead and switching it off, it will be there will be a problem, right? In that case, if somebody needs to have a critical call at the dead end or the dead of the night, then the person will not be able to make the call. So it is not about manual, but AI has to be implemented there, where it will be receiving only at a particular time with a particular bandwidth. Obviously, some bandwidth will be available for the whole time. And then integrated non-terrestrial NTN as well. Now coming to India part. In India, the commercial launch the inflection year was 2022. 2022 marked the transition from the pilots and trials to full-scale commercial development. As you might have known, I'll come to a greater detail later as well. Jio was the world's fastest and largest 5G deployment across the world. So we had pilots and full-scale commercial deployments across the sectors. 5G rollout Post-spectrum auctions were also held. GCC expansions, which is a big talk of the town, being pilot innovation hubs, and quick commerce scale-ups has to also be there. EV ecosystem is also expanding. We see a lot of electric vehicles these days, and these electric vehicles, along with the autonomous vehicle system together, can bring revolution. The Gen AI adoption pilots are also running in the enterprise grade. So what's happening is basically the public launches, the consumer availability, the enterprise onboarding is happening, and there is also a lot of regulatory clarity which are coming in. As a few minutes back, Abhijit was also mentioning, while we are talking, in Delhi, there is AI Summit coming in. A lot of focus will be there on the policies, and the policymakers are expected to do a great job there. That's about this slide. Let's go to the next, which is the 5G key features. Now, let's think about these as the three superpowers of 5G. Let me tell you a simple story. Imagine you wake up in the year 2030. Your world looks familiar, but it feels very different because the network around you have evolved, not just faster, but smarter. And this transformation is powered by three superpowers of 5G. Superpower number one, EMBB, the enhanced mobile broadband. This is the easiest one to understand. It's about the massive data capacity. Simple. If 4G was a 4-lane highway, think about it. If 4G was a 4-lane highway, 5G is a 20-lane expressway in the sky. So that's what we are talking about. So we are talking about speed aspects of 10 to 20 gigabits per second compared to 1 gigabit in 4G. But the speed alone isn't the story. So imagine putting on a lightweight AR glasses. You are watching a live 8K virtual reality concert, looking around freely, zero buffering, zero lag. It feels real because the network is carrying oceans of data effortlessly. That's enhanced mobile broadband. It's not just faster internet, but immersive digital experience. And when we talk about the 6G, if we think about the 6G, it's more about Internet of Senses. That will also be expected. Coming back, 5G. Superpower number two, URLLC. As I was just mentioning a few minutes back, ultra reliable, low latency. Now that's move from speed to time. This is about reaction speed. So it's the time between what something is done and then the response. In 4G, the network response is about 50 milliseconds. That's fast, but not fast enough for machines. 5G brings that down from 50 milliseconds to under 1 millisecond, almost real time. Why does it matter? Picture a surgeon in Mumbai performing a remote robotic surgery on a patient in a rural town. Every movement of the surgeon's hand is mirrored instantaneously. No delay, no jitter, no risk. Or imagine autonomous cars at a busy intersection, making split-second decisions, communicating with each other, avoiding accidents. This is URLLC. Not just low latency, but ultra reliable as well. Life critical connectivity. The network stops being a pipe and becomes a nervous system. Superpower number three, MMTC, massive machine type communication. Now comes the quiet revolution, not about the speed, not about the latency, but about the scale. 4G could support about 100,000 devices per square kilometer. 5G supports about 1 million devices in the same space. That's a 10x leap in connected density. Imagine a smart farm, thousands of tiny sensors in the soil, measuring moisture, nutrients, temperature, drones flying overhead, automated irrigation system, responding in real time, or a smart factory floor. Millions of sensors monitoring machines, predicting failures before they happen. This is MMTC, a world where everything can connect, everything which can be connected will connect, which we called as Internet of Things, but in a massive scale. Bringing it all together. So when people ask, why is 5G, what is 5G really about? It's not just speed. It's three transformations happening together. EMBB gives us immersive digital experiences. URLLC enables real-time mission-critical control. MMTC connects billions of machines quietly in the background. Together, they run connectivity into something bigger, not just communication, but infrastructure for the future. And that's why 5G isn't just an upgrade from 4G. It's a platform on which the entirely new worlds are being built. Okay. Now, a little bit of numbers. Just spot check. My voice and video are still on. Everybody able to hear me correct?
Yes, yes,
Anyone?
yes, yes, yes.
Fine. Now, reality check. Okay. So, according to ITU IMT, which is a governing body of the telecommunication world, the targets and 2020 targets and 3GPP, which is another governing body, the standards, the 3GPP standards, the peak rate under ideal conditions of millimeter wave spectrum, massive bandwidth, line of sight, and low congestion. All these, like, since these are all standards, this will have when kind of a thing, all parameters, like how we usually write formula. So with all these conditions, the specific ideal conditions, the download peak is about 20 gigabits per second. Uplink speed will be 10 gigabits per second. And we have now what does this mean? 20 gigabit and 10 gigabit. This helps in ultra HD streaming, immersive AR VR, cloud gaming, rapid enterprise data transfer. When we say enterprise, it means big organizations. Ultra reliable low latency communications. How is this achieved? So in 4G, we have fixed subcarrier spacing, longer transmission intervals. So in 5G, we are using the flexible numerology, mu. Let me take a moment to describe this mu. Now we have, for example, specific wavelength. If we can divide it into chunks, those you can imagine those as the flexible numerology. So variable subcarriers, they are called spacing. So we have variable subcarrier spacing, which can be 15 kilohertz, 30 kilohertz, 60 kilohertz, 120 kilohertz. It enables to have the shorter transmission time intervals and have the mini slots. That means we have preemptive scheduling. So if necessary being, there will be smaller slots there instead of one big chunk of data going one place to the other. In 4G, we had data in full slots, that is approximately 1 millisecond of a slot. But in 5G, with the predictive numerology, we have mini slots allowed transmissions in fractions of a slot. Immediate transmission without waiting. So there is no need to wait for that amount of infrastructure available, that amount of wavelength and time available. It can be sent into small bursts. Also, we have the non-standalone and standalone, which will be impacting here, as I was mentioning. For a standalone, everything is 5G, the infrastructure is 5G, RAN, core, everything is 5G, whereas a non-standalone, it will have an impact like there will be still some of the equipments which are slow, right? So those, if we are utilizing them, because those are quite expensive ones, that's fine. For some smaller, or if that is not mission critical, or that is not ultra reliable requirement, we can still use it. We are also, we should also have the edge computing in order to achieve these items, like that. Now, what is edge computing? Now, if I talk about the overall infrastructure of any telephone, there is the phone, right? The user equipment, UE, as we say. There's also another slide down. There is the RAN, which is the radio equipment. It captures the signal from a UE to a RAN. Then it goes to the core. Now, from core, it goes to the backhaul system. Now, core is the brain, or the actual item, or the actual infrastructure which processes it. Now, what does edge computing mean? That this processing can be brought as close to the network as possible, so that the latency is less. That's what basically edge means. Edge is bringing the compute nearer to the edge. That's what edge computing is in a simple term. Okay. Now, massive with with the density part. With the density, we have up to 1 million devices per kilometer square. This is the massive machine connectivity. These are not smartphones. Okay, so while we say massive machine, means this can be anything. A fridge can be connected to an Alexa machine. Alexa machine can be connected to something else. There can be, in factories, there can be something, some part of a machine connected to an assembly line kind of a thing. Ports are good examples where there are lots of machines which are connected. So this is not only smartphones, but including them. But more machine-to-machine communications, sensors, and IoTs are there. Sorry. Okay. Now, these, and the last one is the 5-9. That is how we measure reliability, which is, it sets the high standard for service reliability target. How reliability is achieved? By duplication. By duplication, it means if something is failing, then the other can pick up, the backup can pick up. There are various kinds of technology which is used for backup, or various kinds of architecture which can be backup. That the backup can be always running, the backup can be only live when the other, or the main is dead, something. There are lots of technologies which are there, lots of design principles which are there, which enables this reliability to be achieved. So if you see on the right-hand side, the 4G and the 5G illustrative says the comparison between the 4G devices and the 5G references with respect to it. And we see there is a huge difference. When we say 4G is speed high, the first one, the first graph, the speed is much less in 4G, while the speed is much higher in 5G, whereas the latency is much higher in 4G and much less in 5G. Okay. Now, this one I just touched upon now about the network architecture. Let me give you a little bit of brief about the architecture. So the last one that you see here is the UE, which is the user equipment. And if you see, there are multiple things, not only smartphones or laptops. There are autonomous cars, there are factories, there are drones, spectacles, lots of things. These are massive IoT connectivity that we are talking about here in 5G. Then comes the radio access, which is the G node Bs, as we see. These are in the GBTs, that is the ground-based towers that we see. And also another technology is a small cell. Now, what are these? GBTs earlier were big towers installed in either on the ground base or on top of any building, which can cater to a large area. And then you will see rectangular boxes high up there, which are tilted a bit. That tilt can also be electronically, and by AI it can be controlled. So those stills are basically giving the area in front to cover. They are receiving and giving away as well. So these are the massive in and massive out, MIMO, as we were saying. Now these will be communicating with each other as well, and then handing over when we move from one cell to another. Now, what is a cell? Whenever we say that an area is covered, we divide it into various cells which are honeycomb. I think if you are coming from EC background, you'll be knowing mostly about the cells. So when a person is on the move and is over the phone, hardly these days we feel any jitter in the connection, because these connections are handled, or these transmissions are handled very smoothly from one tower to the other. When we talk about 5G, this cell sizes are actually very less. It's kind of having one cell in my room, and the adjacent room has another tower associated to it. So these are small cells. When we have the radio access network, after the radio access network, we have a transmission layer, which is somewhere here, and this goes to the core. Now, what does core has? Core has MFF, SMF, UPA. There are lots of items which are there. Previously, we had HLR. Now, these are different kinds of functions. What functions? These are network functions. And then these network functions are gradually moving to virtualized network functions. Previously, at the very onset of 3G and all, these network functions were attached to a hardware. Like our SIM was attached to a phone, these network functions were attached to a hardware. So for any AMF, if a person is, let's say HLR, if somebody is buying an HLR, which is an home location register, then it's a hardware box. Now what is happening? These all network functions are transferred, have become softwares. So buy any hardware, be it from Dell, be it from Ericsson, be it from any other hyperscalers, buy from any of the hardwares and put a software on it, and it will become any of your network functions. What will the network function do? Network functions will have various kinds of activities of their own. They can have the activity of, for example, to check if the user is authentic. They can also be used for like handing over to an internet, for example. So there will be various functions which will be used. So these are the virtualized network functions. Now comes the cloud-based network functions, where these network functions can be hosted now in the cloud. So you see cloud services and edge computing are also coming in. User equipment, handing over the things to radio network to the 5GC core. GC is 5G, and then the core system here. And in between, there are transport layers and backhauls, and end-to-end 3 interfaces are there. These are different standards defined by ITU, GSM, and 3GPP. Okay. Lots of technical term. I hope I'm trying to make things as simple as possible. Now, how is this being implemented? What is the technology behind it? One is the millimeter band. What does millimeter band means? It means it has high frequency, 24 gigahertz to 100 gigahertz. It has a wavelength 1 millimeter to 10 millimeter long. That's why it is called a millimeter wave. And what do we achieve out of this millimeter wave? It's a huge bandwidth. In 4G, we had 20 megahertz per operator. It has very high throughput. So multi-gigabit per second as a speed. And these will be used for stadium hotspots, airports, dense urban zones where we have a lot of requirements of bandwidth. Now this has pitfalls. So the pitfall is short range, because it is like after every 100 meter to 300 meter in urban areas, it will be dropped. It is sensitive to blockage. If there is a thick wall of something, then it will be blocked. It has very poor, not very, but poor indoor penetration. With all these problems and all, there are still some solutions. The beamforming is a solution. As I was mentioning, if you see the towers which are there in different buildings, on top of different buildings, you will find a tilt. So those are the core enabler beamforming tilt. We have the massive MIMO plus beamforming. So think of this as a flashlight instead of a bulb. Okay, so where it is going and which area it is catering to. Now, this comes with the dense small cell architecture mounted on street poles. Now, these days you will find the lamp post. On top of the lamp post, there you will find small um, devices with some antenna there. Those will be the street poles mounted, and it can be in buildings, it can be in stadium, infrastructure. Those are not the repeaters. Mind it, there can be some repeaters inside our home. Sometimes we buy them. Those are not the repeaters, but then actual transmitters, which is used considering a small cell. Also an intelligent handover. Now millimeter wave was for speed, and mid-band 5G is for coverage. With the use of AI in the network, the performance improves a lot. Now in India 2022 auction, as I was just mentioning earlier, 26 gigahertz millimeter wave spectrum is the 5G auction. And then Jio, Airtel, and Vodafone Idea selectively, I think, acquired their holdings. Okay, so next comes, let's see what the global trends in this sector look like. Lots of things that we are saying with lots of technology, lots of terms that I have thrown to you. What is the global sector? What is the global telecom sector thinking about it is? Now, the first one is on the networks and the infrastructure side. While we have the cloud to edge continuum, it is distributed cloud topology. That means the cloud will also evolve. So hierarchical compute planes are coming into the picture with different kinds of cloud: central cloud, regional cloud, edge cloud, device edge. So these are basically key enablers of software-defined infrastructure fabric, as we say these days. Okay, then the thing also associated here is the edge computing. So if we say this is an edge native architecture, we use native term these days a lot. So edge native architectures are in the edge is moving beyond the CDN style deployments. It's future edge. That means stateful. Stateful is whenever anything which is stateless and stateful. Just give you an example. If any program is once it is switched off, and then when it starts, it does not have any idea what it did in the past. So that is stateless. And stateful is it continues with all the previous information. So we have the stateful edge computing. We have the edge training loops, and that means one of the edges will be training the other edge in the next leaf. And also there will be federated intelligence. Now this is coming with a lot of sovereign data, federated intelligence. These things are also coming. You see a lot of things in the news. Because with all these data sharing, now the countries are quite sensitive on what kind of data are being shared. So once we have the data which is inside or what it's protected by the country laws, we will have the federal or the federated intelligence as well. That means we will not be overusing or undermining any kind of laws of the country, laws of the land, as we say. There has some challenges as well. So it has consistency models as a challenge. It's not very consistent overall. Every TSP will have their own implementation, as you will see in three different cases that I'll walk you through at the end or towards the end of this session. The edge is not observable enough. That means we do not know what exactly which edge is doing what. That is still under uh, implementation or still under design, and a lot of distributed trust as well. So uh, the companies are the equipment makers are still bringing this up to the speed so that it has built trust in every user's mind and in every, be it enterprise or be it customer. Also, the sovereign and the regulated clouds. So here, the geopolitics with fragmented cloud are there. So we have air gap clouds, we have sovereign clouds. There are a lot of items which are there in these. And geopolitics is one of the chapters that I will be, or one of the section that I'll be taking later. So I'll be more detailed there. Also, another very important is defense grade compute fabrics. So this is one of the trends that is coming up, is how the defense data will be used in different countries. And while you see the different giants of the powerhouses of the world, uh, the war is no more only on the ground and by soldiers and by like bullets. Those are information wars and data wars also going on. Architectural implications are there. So we have the compliance awareness orchestration. We have the intelligence layer, AI as a foundation infrastructure, and foundation models as platform. Now, let me tell you about the Moore's law here. So once we have uh, the what Moore's law says is, I'm not sure if all of you know that every 10 years the number of sensors in a chip doubles. So that's what the Moore's law says. And with the shift from Moore's law coming in with all the AI is, instead of one big chip, there will be chiplets, which is the smaller chips. Each of them will not have double the items, but they will be more reliable in what they can do. That's how the newest technologies are coming up. With again, the AI revolution is there with AI shift from being the generative one with the decision making with the human in the loop. HITL is human in the loop. So whatever the things are done by the AI, there has to be some human which can take a decision if this is right or wrong, depending on various factors. Like if it is right in some country, it can be wrong in some other country. So human in the loop is very important. Uh, with this, the agentic AI things are also coming in. For example, if I talk about telecom, if you think about agentic AI, it can be a billing system agentic AI with which generates a bill, and then if the person is faltering, then it goes to a collection system, right? So there will be some fine, etc., which will be going on. So if that is, if you say this is very simplistic idea, but this is what, this can be the starting point of the agentic AI as well. However, agentic AI here is meant to be a lot more complex. So we are talking about the AIs which can modify the network as per the need. Okay. Then it comes about the sustainability and technology drivers. While we say that there are these data centers coming up, these are the huge items which are coming up, or the huge devices which are coming up, the energy consumption is also becoming a bottleneck. So the trend will be going towards green RAN, green core evolution, as AI is also kind of a double-edged impact. Edge here means normal edge, right? Like a sword. So AI is double-edged impact. By that, what I mean is, if AI is being used, then there is a lot of automation which is being achieved. Also, for using the AI, a lot of power is required. So that's what is meant. Geopolitical shift. This is a big impact on telecom these days because one who has the technology in hand has the power, right? So there are techno blocks, sovereign data, vendor competition is there in some of the countries. Some of the vendors are blocked due to some geopolitical reason, etc. So with All these, there are two things. One is one vendor is competing with the other. Also, the vendors are collaborating with the others as well. Like one of the vendor can sell off some of their portion, which they say that, okay, this is not my core business. Let me sell this off to a person which can take care of more sophisticated way, or then take care of the R&Ds and all, because that is one of the system. For example, if I am a core business, I want to sell off my BSS OSS part to some other company, I can do that, provided that the next transformation project that I am getting, I will have the other organization do the BSS OSS part. I remain focused in my core. So instead of competing, there is a collaboration approach which are also coming in. And the hyperscalers, open technologies, and API exposures are also there. Hyperscalers, that means the big organizations which are providing cloud, they are also working with each other. If you see any kind of how AWS works or how Azure works, they will have their facility to use some part of the other one as well. AWS will be able to have a mixed cloud of AWS as well as Azure. Similarly with Azure, this is kind of collaboration that the hyperscalers are going in to be more acceptable by the enterprises and the customers, mostly by the enterprises. By open technology, I mean open RAN, open core, where it is by the standards. If the standards are maintained according to the 3GPP, all the items which are built there will be able to talk to each other because they're standardized. There is nothing, any specific item are there. However, usually it happens that there is a, a wrapper which is needed for any of the technologies to talk to each other. API exposure is one of a very key area where any of the APIs can be used in some other industry. Let me give you an example. The usage of my telephone can be, if I'm okay with this and it is not very sensitive, then the API can be exposed to share, for example, which of the clothing I can buy, or which of the uh, weather conditions is I am okay with. Okay. And then there can be business analytics associated which used the API exposure as well. For example, by using the data which is there in the internet, there in the telecom infrastructure, only by data and phone, data and the voice, those data can be utilized for any other analysis which can be done by the telecom service provider or by any other enterprise. This is done by APIs and it is called API exposure. There are a lot of governance which goes in API exposure, not that every information can be shared. And if it can be shared, that will be very secure, and all the cybersecurity things also come into the picture. So that is one big area of the global trends here. Okay, then quickly I take you through the 5G subscription. There are very interesting facts. These are from very reliable source of 5G subscriptions in 2030 will be approximately 6.4 billion. IoT devices will be more than 38 billion, and AI investments globally by 2030, according to McKinsey, will be 6.7 trillion. Quickly to the telecom industry understanding of the India market. Now, this is what I told you about the global market. In the India market, the 5G being a default will be it is still there are some of the areas where we see 3G, where we see 4G, but then upcoming market 5G will be the standard, 4G will be a fallback layer, and 6G is where the pilot phase comes. 2030 is when 6G will be formally introduced. However, we should see at the initial years of 2030 onwards, we'll have the pilot phase of 6G. The enterprise 5G and the private network surge shall be coming in in the Indian market, which will have the ports and the campus networks and the edge computing, edge and AI computing. I was reading about campus, interesting one, but for the interest of time, I will go ahead with the others. Okay, so then comes the fiber 5G satellite hybrid connectivity, which should be having the fiber backbone as the main thing which is going on. 5G as the fixed wireless access and satellite broadband as well. These will be the hybrid connectivity part. So wherever there is possibility of whatever is best, it will be optimized there. The massive infrastructure localization, which is again the Make in India. There are radios and antennas, core software stacks. If you see, Geo has mostly built of its own local things. Also, other big equipments are making their research items here. The research facility is here where they build the radios and antennas from India. So other organizations are also coming in, and AI native is absolutely the thing which has to be there with autonomous network, zero touch operations, and AI native OSS and BSS. Okay, so all the good things, but what is the challenge here? Okay, give me a moment. Top challenges. Top 3 telecom challenges, according to most of the trusted sites here, is monetization crisis in 5G and 6G transition. Think about it as if your electricity board says that use as much electricity as you want, and we will charge only 500 rupees per month. How will it be? So this is all happening with the telecom these days. The core issue is telecom is investing at tech company scale, but earning at utility margins. It's tech company, so the investments are high, but telecom has become a utility. So the earnings are low. Now let's understand what we have now. We have trillions invested in 5G globally. We have the 6G capex already beginning. We have the ARPU growth, which has stagnated in most of the markets. Meanwhile, the value capture shifts upwards. So we have the hyperscalers, which will be charging for the platforms, the AI companies, which charge for each of the apps. So the paradox here is that telcos build infrastructure, bear capex risk, and capture limited upside. Why it gets worse? After 2026, AI traffic explosion will be big without pricing power. So, and then the flat rate data models are killing. Consumers' willingness to pay has plateaued, for example, and this is also a lot of created. If you know that we are most of us are using the 1 year gold subscription for ChatGPT, right? So once that is over, probably we will have to pay. So this is kind of created the need, and then people will have to pay for that. The survival levers for the telecom service providers, on the other hand, is nothing but the network APIs, which has the open gateway, the enterprise platforms, edge monetization, private 5Gs, but the scale and the margin remains uncertain. Also, the geopolitical fragments of the telecom ecosystem. The core issue is telecom is no longer is just infrastructure, right? It is strategic national infrastructure, and it has a lot of sensitive data as well in it. So the fragmentation trend is the vendor polarization. Emerging blocks like the Western stack, Ericsson, Nokia, they have the Open RAN. The China stack, which is the Huawei ZTE ecosystem, and there are the countries where one is allowed and the other is not. So the operators are forced into non-technical vendor decisions. This is not technical, right? Who has the better system? There is nothing like that. But then this is just because some geopolitical situation we have to use. Now we have the sovereign telecom stacks. The countries are pushing for sovereign cores, localized cloud, because once we have the cloud infrastructure known and then all the facilities we know are very good, but then we know the data of one country is going to the other, which may not be acceptable after some point of time. And then people are also doing the domestic manufacturing, as I was mentioning about geo. So the drivers here is security, the data sovereignty, and industry policy. Now the supply chain weaponization here as semiconductors, radio, and software stacks, which are becoming geopolitical leverage points. The standards as soft power are also battles which are moving into 3GPP influence. So people are going and influencing the lawmakers as well. There is 60 research alliances which are being influenced. We have the Open RAN coalition. So whoever controls the standards has the future of the market control. So these are various areas where we have challenges and we need to make sure that it is good for the planet. Now, there is long-term risk as well. The fragmented global telecom internet, the potential outcomes can be regional telecom stacks, incompatible ecosystem. So once we have the ZTEs differentiated um, with the Nokias of the world, those can be incompatible at some point of time, and slower global roaming innovation. While we are moving from one country to the other, there can be a problem because they are not working together. Now, number three is the exploding network complexity. So we have cloud, we have AI native, we have edge, we are moving towards 6G. The complexity is unthinkable at this point of time. So networks are evolving. They are evolving from hyper distributed to AI driven software systems. The traditional telecom ops model cannot keep up. So the complexity drivers are different, like cloud native are one, AI native networks are one, edge, and moving towards 6G. The other one, the last one here in the top challenges is sustainability, where I was mentioning about the power need for any of these data centers or any of the equipment keepers are keeping very high, while we have the network densification with the small cells, as was mentioning. So with these networks densification, the AI traffic explosion, cloudification of the telecom, we need to take care that we are not doing any harm, or the telecom companies are not doing any harms to the Mother Earth. So that's the sustainability part of it. And here comes a picture. This is from McKinsey. It shows about the global data center capacity. It has both AI and non-AI workload as well. The graph shows from 2025 to 2030, where we see a 3.5x change. So you can understand how much the data capacity or the data center capacity demand is growing with a continued momentum scenario. And this is in all in gigawatts. Okay, now I think we have talked about the small cells already. This is there are different types: femto, pico, micro, etc. And these are very ideal for different kinds of smaller initiatives like campuses, metro corridors, stadiums, and malls, which is less amount of coverage which is needed, but backed by users. So that's where we use the small cells. Okay. So, shall we move to the activity, or we go ahead with this?
I think
Yeah.
we have we have explained this as a
Yeah.
part of previous slides.
Mm.
So instead of making it a monologue, let's quickly go into the activity. But before going to the activity, I think we need to cover IoT and Internet of Things as well, right? Because the activity is around that.
Yeah.
Okay.
Excuse me.
Yes.
Is there any software using which we can interact by using ML with those 5G infrastructure?
Yes, we can. Yeah. We can for the programmable networks. We can. If you're talking about any software name, I don't think we have any software name specific, but the machine languages can be used a lot for learning how the network has been behaving at this point of time or throughout the areas. And then it's a very good use case for identifying any problem which can occur and fix it early, even before the actual down happens in the network. So whenever there is data passing through the network, if there is a congestion expected, then by the machine language technologies, we can identify that and we can fix it by, again, agentic AI can come into picture very well here and fix it even before the issue occurs.
Okay, but is there any kind of means how this is this possible?
Uh, okay, let me give you a brief about then the OSS, which is the network management part. The network management part is responsible for for changing any kind of parameters which are there for network management, like for the bandwidth purpose as well. If there is X hertz deployed in one city where there is one kind of congestion which happens for every initiative, which is like Saturday evening it happens, then for every before once it is learning with the data, then once we have implemented the machine language, then after a certain amount of learning, it can very well have additional bandwidth allocated to that part of the city where uh, there is a chance of congestion in the 6G. It's about allocation of the bandwidth. This is just an example for solving any problem, and this is one of the cases where machine language can be used very well.
Okay.
Yep.
So we quickly move on to the next topic, which is Internet of Things. So have you all heard about this term, Internet of Things? Maybe a show of hands. Because we were talking about internet till now. We were talking about data connectivity, but what is Internet of Things? Okay, I see two of you. Okay, so let me try to give you a simple explanation. There's a diagram out here which shows that, and we spoke about network being the foundation on which we can connect between all kinds of devices, and all these devices we are terming as things in this particular diagram or architecture, whatever we call it. And what we are essentially trying to do is to effectively use these things as in inverted commas, talk to each other using this 5G network or this wireless network. Let us assume for the time being that we are talking about 5G, because that is where we are now in India. And typically, if you look about applications of how devices talk to each other, then maybe if we start at a very basic level, let's think about smart home automation. I think when this entire subject came into, I mean, surfaced around quite some time back. I think it was around somewhere around 2009-10, or even a little earlier. Some of us actually tried to do a smart home automation using a Raspberry Pi. Right. Now, if you think about smart home automation, it is much beyond that, and there are ready-made appliances, connectivities, remote controlled operations which are available. Though there are, if you have a chance to visit GTEx at any point in time, which happens in Dubai, which is a large electronics and IT fair, or if you have chance to visit some of these low-cost items which are available from China, you would see the kind of, or the variation of home automation options that are available today. And starting from controlling lights, starting from controlling, if you move into a room, the lights will automatically switch on or off. You control your appliances, different kinds of household appliances, security systems, including CCTV systems, using voice or even smartphone apps or even a remote control. So it starts from switches to fans to televisions, and all kinds of automations are possible using putting all these devices on a common network and talking to each other. There can be environmental monitoring systems. There can be systems used in agriculture. There can be systems used in fleet management. If you are running a logistics company, you would probably need to manage your fleet. And it all starts from a sensor collecting the data and passing it on to probably a central server somewhere. And you would want to understand the different analytics based on the data that is captured through those sensors. If you have a large fleet moving between Calcutta to, say, Delhi on a regular basis, and you are a transport management company, then you would probably want to understand how your fleet is moving across the different intermediary cities or stations, and kind of analyze as a company, try to analyze how effective that movement of fleet is based on the data that you are collecting from those sensors. A lot of usage are coming up nowadays in healthcare using different kinds of wearables and attachables. So I was just, one of my friends got a Ray-Ban Meta a few days back from Dubai. I think it's available in India also, in Amazon as well. And I think the data captured by all these kinds of wearables, attachables, either in the form of any signal or any video or audio interventions. There are blood glucose monitors, there are blood pressure monitors, and practically, when you are thinking about the next stage of healthcare, which we are calling, in industrial terminologies, we are calling it value-based healthcare systems. The data that we are collecting through these wearables and attachables from a patient, and predicting what can happen to a patient, pushing it to the nearest healthcare provider to get more ready medical attention is something that is coming up very widely. It is prevalent in most of the developed countries. It is coming in India today. As we are speaking, in healthcare, robotic surgeries, these kinds of tracking and prediction of health, ill health, through data collected through wearables or attachables are developing very rapidly. And for monitoring patient activity, even we were talking to one of the hospitals in Calcutta. We were trying to develop a homegrown smart fall tracker. So think about old age people who are probably in a home alone. And if he kind of have a device attached to his hand, which detects a fall, right? And that signal is passed on to his son, who is staying in, say, US. And at the same time, that signal is passed on to a healthcare provider where he is registered as a patient. Then think about the kind of turnaround time that can be enhanced in giving him the kind of treatment that he needs, because that person might be all alone in his home. So all these things, I was starting from the simplest applications in home automation to healthcare, to vehicle management or fleet management, to smart agriculture, to industrial automation, which, say, for example, if you are working in a manufacturing setup, and typically if you are aware of the ISA 95 architecture, and starting from the sensors to the control layer, to your the integration layer, which is typically the manufacturing integration, to your business applications, which is your ERP, which gives you a real-time visibility of how things are happening at the shop floor. So all these happen through obviously the connectivity being the foundation, but the underlying concept or the technology is known as Internet of Things. Now, it can be extended to a lot of other things, like if you want to track assets in a warehouse or in an organization as a whole. It can be used in waste management. It can be used in traffic management, in a better traffic management. In fact, I was in one of the events today, and some of the aspiring entrepreneurs were trying to talk about how this can be used. A combination of AI and IoT can be used in a more smarter traffic management system even in West Bengal. I think when we think about the technology, so I was talking about the application and how it applies to the different industrial sectors. But when you think about the technology part of it, I think the base three components, if you look at it, one is the microcontrollers, which can be even something as simple as a Raspberry Pi or a Arduino. The sensors, which I was talking about, myself being an instrumentation and electronics engineer, sensors is something that I have learned for all those 4 years. And as I said, and since this is a topic around telecommunication, communication protocols, while most of the times we use Wi-Fi, which is a subset of the overall network, the network provider network that you are using. But you can also use networks like Bluetooth, BLE, or even MQTT. Infrastructure, as I said, again, is a foundation to all of these, because there would be even if you are talking about or thinking about Internet of Things and its applicability in any of the sectors that I spoke about, or any of these applications that I spoke about, please keep in mind that there would be a lot of data that would be exchanged every minute or even every second. And the storage of that data or the maintenance of the data is very important to analyze that data correctly, to get meaningful outputs or predictions, or even to use AI at a next level, or the LLMs at a next level, to do better predictions, right? So it is very important that you create those or you arrange for those infrastructure in terms of cloud. And most of the cloud providers today, the hyperscalers that we know about, they have this IoT even as a service provided to you, and you can use it, work on it, write your own applications and try to test it, how it works even for a simple smartwatch, how that data is collected, data of your, say, for example, the number of steps you are taking over a week. It picks up that data, stores that data, and helps you predict, uh, whatever health predictions you want to make based on the number of steps or the calories that you burn over a week or a month. So key three things to understand: the technology, the infrastructure, and the foundational network. But at the same time, while technology is the key to it, it is also important to understand where to use it, right? Because if you are not using it in the right place at the right time, the technology is of no use. So we call it in our industrial terminologies, we call it use cases. So if you are not identifying the correct use case, even if you are developing the greatest technology applications of the world, it is of no use. So the way we, if you think about the block, right? The blocks, the three broad logical blocks that we need to understand. And whether you're talking about IoT, whether you're talking about AI, and I'm coining AI because AI is everywhere now. Everybody is talking about AI. The first part is the business need, right? Whatever sector you are in, whatever geography you are in, whatever function you are in, there is a business need that needs to be addressed. Then there is the engineering layer, which talks about the core engineering that we all have learned in our engineering days. And the third part is IT, which enables engineering to solve a particular business problem. Now, if we connect this tree and do it in the right way, then only that problem is solved. So if you are thinking about Internet of Things and applying it, even in the simplest form, then you have to understand this blocks which are working together. Next slide, please, Paromita. I think we spoke about this. Let's move on. Okay. So the next important topic that we would want to cover here is smart cities. And we have tried to create, for all of your knowledge, this is not something that Paromita or myself have drawn, but this is something that we have skillfully drawn using one of the LLMs, right? So is it making sense to all of you? Are you understanding at a very high level? If you look at this diagram, is it giving you an idea about what smart city is all about? Can anyone try to answer, please? I'll cover it, but looking at this diagram, is it giving some idea? Can you give me an example of a smart city? Any one of you that you are aware of in India? We have one in Calcutta also. I mean, Greater Kolkata. We have one, at least to a large extent in Greater Kolkata. Do you know what that part of Kolkata is? Are you all from Kolkata, by the way?
Yes, sir. It is in Newtown.
Okay. So if you are aware that Newtown is a smart city, can you help us with 3 points or 2 points what you have seen or experienced as a part of a smart city in Newtown? It is Mr. Debashish Sen, who's the architect of Newtown Smart City at one point in time.
Yes, sir. It's birth certificate is already taken using blockchain, and even the maintenance work are carried out, and electricity consumption nowadays is measured using some automated devices or like this, which are integrated in IoT devices like this.
Okay. Okay. Any other thoughts? Any idea of the advanced for smart cities that we have across the globe? Okay, let's try to understand.
Sir, can I speak something?
Yes, please.
Okay,
We
sir.
are trying to make it interactive.
Absolutely. Okay, sir. What I have seen in smart cities like us today's, like when I am driving by my own scooty, I find if I lose some track, that there will be a challenge generated, I think. So I think that smart camera, which is already recognize what is my actual thing or actual, I am not maintaining the law, so it will create the things naturally to my phone. Like you have passed this red light, so it will be around 500 rupees for this. So I think, is it around smart city things?
Yeah, we can definitely call it a component. I think somebody has
Okay,
to
sir.
go on.
Okay, sir. Because sir, I see these things, all city surveillance, all number plate recognitions, all traffic systems. Like nowadays, these are truly huge things.
Have you used smart parking anywhere?
Yeah, sir, exactly. I've seen there, like
What
in
happens?
when I was in Bangalore in for 2 days, and even I'm in at Silchar right now. What I've seen in NIT, there is a parking management system. Like when you are park your car, if that is not that particularly point, then it should show like a point that you cannot park here. Already your this parking is booked. You can park on P2 or P3 or P4 like this. So is it like this, sir? I exactly don't know. That's why I'm asking.
Let me. I think somebody has to go on mute. Otherwise, it's echoing.
Okay. Hello.
Can you go on mute, please?
Yeah, Tathagat or Raikesh, please mute.
Yeah, exactly. Okay. Thank you, sir.
Yeah. Otherwise, it was echoing. So, what I was trying to say is, yes, you are, correct. So, it starts with very simple things like smart traffic systems, right? So if you are crossing a particular, so there are cameras which are fitted everywhere, and probably after a certain distance, and it will kind of capture your speed limit, and it will let's think a little beyond capturing a speed limit. Let's think about a sensor which is there in an ambulance, which if that ambulance is taking a patient uh, to the nearest hospital, and at runtime, using the GPS signals and all the the updated signals that are coming in from the traffic posts, using cameras and other kinds of, because see, nowadays GPS, if you use Google Maps, it gives a fairly accurate measure of what kind of traffic is there in your route. And if you ask Google to do a route planning, it will do it for you. But if you want to integrate it in a small part of your city, and you want an ambulance to reach the nearest hospital with a patient who has, say, who needs a particular treatment. Think about a system which is created, which connects the patient to that healthcare provider, right? To that hospital, I'm saying, where that treatment is readily available, and tells the ambulance that this is the route you should take to take the patient to that hospital in the least possible time. So it's an integrated system which captures the GPS signals, which captures the real-time camera signals from the different traffic points, and it also integrates the data of that healthcare provider, which has a list of doctors who are available at that point in time in IPD to take care of that patient, which makes it smart. So why we are calling it smart? Because by integrating all these technologies together, you are actually able to make the life of the resident easier. We are talking about smart buildings, smart parking areas, smart waste management. We are talking about smart traffic, right? All these together, and if you see this diagram now, you will slowly try to relate a public safety network. In think about if you are all aware of Newtown, and there are certain remote areas of Newtown, where there are even offices, and there are our lady colleagues, there are female colleagues who work late night in those offices. So say, for example, they need some kind of safety when they come out of their office at 9 p.m. or 10 p.m. Just to ensure that they are safe, can we have an infrastructure provided to them? It can be as simple as a wearable device which transmits some kind of signal to the nearest police station, or even the police outpost, in case she feels that her safety is compromised. So it is around public safety. It is around street lights, right? So instead of depending on some control system which needs manual intervention, can we automate it through an intelligent device? Well, the answer is yes, right? Smart traffic management. We have spoken about an ambulance reaching and I heard this, this story was actually given by Vodafone in an event which I attended, I think, around 10 years back. This ambulance story that I told you. And why Vodafone? Now the question is, because Vodafone was trying to say that we are providing the network and the foundation to help you connect all these systems together. You might have to build some apps and some connections or integrations, as we call it in technology terms. But I'm giving you the foundation. That is what Vodafone told us. So connected vehicles, while it might be a little time when we see connected vehicles in India or autonomous vehicles moving in India, but it is a reality in other parts of the world. So think about all these things coming together and the kind of data that gets exchanged on a even hourly basis. So what kind of infrastructure would be required? And when I say infrastructure, I'm talking about the technology infrastructure. What kind of data packets would be required to carry all these data on a real time. So that is why we are always saying that even if you are thinking about IoT and smart cities, even creating a building smart would need a lot of strength in the infrastructure and the connectivity that we need. And 5G essentially is providing us that. With AI native connectivity is coming in, I think we will, and as Paromita was mentioning about intelligently shifting the network based on the data, on the load. I think with all these coming into picture, when we get into late 2026 or even beyond, not even 6G, even at 5G, we would have the facility and the potential to create multiple such smart cities even in India. We have quite a few of them running pretty well in India as of now. Newtown is also doing pretty well. I would request all of you to go to Newtown, understand and identify the smart city interventions, and yourself see and understand how it has made a change in the life of the citizens staying in that part of the city. So with that, I think we'll speak a little about satellite internet and Wi-Fi 6. Little, I think, Paromita, you can spend 2-3 minutes, and then we go into the activity.
Okay. Okay. See. Okay. We go to. My screen is still visible, right?
Yes, it is visible.
At the moment, it's not showing for me somehow. Let me stop the share and share again. Some problem. Stop sharing. Now, are you able to see my screen?
Not yet, Paromita. Would you want me to share it?
One last try, then I will request you. Share.
Yeah, it's coming now.
Okay, fine. So very quickly, so the Wi-Fi 6 is basically the Wi-Fi, which is the faster Wi-Fi, as we see. It's the more efficient one and smarter, as we see. It is for the office, airports, and campuses. The OFDMA, which is the orthogonal frequency division, multiple access. So FDMA, TDMA, we were mentioning earlier about. Now it is the OFDMA, which is the orthogonal frequency division multiple access. So instead of serving one device at a time, which is the older Wi-Fi, the Wi-Fi 6 splits the channel to smaller channels, which serves as the multiple devices simultaneously. The impact is we have the reduced contention, we have the lower latency, and we have the better performance. And again, in the TWT, which is the target wake time, instead of constantly checking the network and have the wake time ready, it can be woken up only when it is needed. It has the battery safe, as I was mentioning in sometime later. It is about being more sustainable. So Wi-Fi 6E is the Wi-Fi 6 plus the new spectrum, which is the 6 expansion. More spectrum of to 1200 megahertz of new bandwidth, region dependent. Some areas for India, it is 1200 megahertz, and it has wider channels, 160 megahertz, less congestion. What we are achieving by all this? We are achieving the cleaner spectrum, we are achieving wider channels and less contention. Quickly on the Li-Fi, which is the light fidelity. It's considered as a light which goes the visible length, so it has problems like it can be obstructed by any opaque object. But if it is visible or it is in the line of sight, it is super fast and can bear a lot of data together. It is ultra fast, low interference and it is suitable for classrooms, labs, and offices. The LEO, now the satellite with the satlinks, etc., are coming. The big players are in the market. This technology of LEO satellite, which is the low Earth orbit satellite, is covering a wide range of area. It connects the rural, the remote regions where placing the GPTs is difficult. For example, high mountain areas of Northeast, though there are GPTs there, but some areas still cannot be covered. This one is very suitable for the LEO satellite is very suitable for them, and the backhaul and the redundancy for the national networks. So as I was mentioning, the transport layer can be utilizing this LEO satellite internet. Now we come to the smart city activity. Now let's have a connectivity plan where we should have mobility, utility, safety, and environment. Abhijit, you want to brief about how we want to go about with the activities?
Yes. So I think we are at 7:22 now. And the next part of the session is only covering the case studies. Right, Paromita?
Yes, 3 case studies I have.
So that will need at least 15 minutes for you.
Sure.
So which leaves us around 20 minutes or 15 minutes, because we'll also need to keep some time for Q&A. So 15 minutes for activity that we want all of you to do along with us is to, based on whatever we spoke about till now, around connectivity, 5G, IoT, smart city. Let us try to create a smart city connectivity plan. And you can form groups if you want, if you all are together, or if you all are separately attending from your own laptops, then maybe you can try it on your own. First, I think, as I said, you have to understand the objectives, and there might be multiple objectives. You can select one or two, which you can call it which you can crystallize to an use case. So let's start from the third block here, which we are talking about use case. So let all of you start with one or two use cases, then create the block architecture. Right? You can use PPT, you can use any other tool if you want, and then talk a little about how you will do it and what will it do. Right? So we need answers to an idea that you have of a smart city connectivity plan, which talks about the what and how. Just one slide with blocks, and you trying to now teach all of us as to how it can happen. It is just an ideation exercise that we are trying to do based on all that we have discussed here. Can we start now? So 17:25 is the time now. Let us take 10 minutes. You can discuss. I mean, we will go on mute. You can discuss. You can brainstorm. You can share your screens in whatever ways you want to do. I mean, Pritimoy, maybe you can select a few of the participants to be the leaders for this, and they can kind of drive it as a group activity and then present it back to all of us.
Okay, okay, definitely.
So we will expect a presentation, one slide from one or two groups around 17:45, which is 20 minutes from now. But let us not all go silent during this phase. Let us keep on talking. Otherwise, we'll all go asleep. And a few fights are also welcome. In the meantime, if you have any questions, you can ask on this activity. It's kind of a lateral thinking exercise. So, I mean, to arrive at the conclusion, if you have any questions to arrive at the conclusion, you can ask. I hope you all know what a lateral thinking exercise is.
Mm. it would be good that if you raise your hand and tell me who among you is doing this exercise, because 20 minutes, just raise your hand so I can understand, please. Okay, Deepakesh Wari, thank you. Only one.
Hello.
Yes,
Hello. Can you hear me, sir?
yes, yes, yes,
Sir,
yes.
I have a just query that how we are linked the geoinformatics in this smart city connectivity plan. Is if you can some if you say some examples and uh, how to do it using geoinformatics. Basically, I am in the geoinformatics discipline people, so that I have much interest about this. So if it is say something on this
Let,
topic.
let me take it first. By geoinformatics, what will be the modules of information or the data that you will have for any city dweller? Can you tell me that? Will you have the
Yes,
location?
yeah. If we have the um, uh, urban plan infrastructure mapping, the satellite data or the drone data, or the
Mhm.
photogrammetric data, if we have a particular cities, and
Mhm.
then if we have the GPS data in these particular areas, and
Mhm.
then the next process is how it is how we are doing these things.
It best will be to take from the use case. As Abhijit was mentioning, we call it as a use case. The use case are not for the purpose of technology, but for the people of the city. So if you think about a user, meaning a resident of this smart city, what kind of usage this person can have from your smart city? If I call you as the architect of the smart city, will the person be able to navigate through the city while he or she is in need for any kind of medicine or any kind of traffic information that the person needs, any kind of government need that the person has, for example, an update to an Aadhaar card or something. So think about from the user's perspective what this person may need when the locations or the geoinformatics that you are telling about can come into the picture. Also think about the security part, not only the physical security but the cyber security as well. Both are very important. I think for the physical security, this your geoinformatics will be very useful. If there is, for example, a nearby accident which has happened, will the geoinformatics or will the information or the data that you are talking about you have or your smart city has, will it be helpful for the user or the resident? What do you think?
Yes,
Thinking
yes,
that
yes,
those
yes,
lines.
yes, yes, yes.
So just think about what I tried to explain of the three blocks. So think about the citizens as consumers here, right? Consumers of your application, of your system, whatever you are developing. So the engineering and technology comes later. So you have to first think about what the citizen or the consumer wants. In case of a smart city, the citizen is the consumer. So what could have actually helped the citizen in terms of functionality, in terms of need. If you can think about that first, crystallize that first, which we are calling the use case, then geoinformatics or something else, whatever is the technology or the engineering component that will be used, comes as a second step, where we do the design of the system or the architecture of the system, right? But first we have to understand what is the need. And that is why we have tried to create this exercise. See, we have always seen this, Dave, to answer your question, research in academics and research in industry. So we all have studied some stream or the other. And I am very closely connected with academics also, and a very strong advocate of industry academia collaboration. Now, what we have to understand is academics, while we are doing a lot of theoretical study, we are going into depth, we are doing a lot of research. At the same time, academicians will have to understand what is going on in the industry, what solves the business problem. Now, on the other hand, industry people like us will have to understand that while we are trying to solve this business problem, what technology or technologies or what deep research can actually help plug in that solution. So unless and until we shake hands, our brains kind of converge, the best solution will never come up. But the starting point, as Paromita said, is always the need of the consumer. It is the use case.
Okay, sir. I,
Are we
I,
clear?
I understand that. Yeah. But basically, the need-based application is required to apply these geoinformatics tools. How to solve it? It is very important things. Okay.
Yes. And I think Paromita has given quite a number of examples which will help you, pick your brains.
Okay, sir. Thank you. Thank you, sir.
Thank you.
So it should be good to know how the exercise is progressing. Now the 7:38, so 7 minutes remaining.
Okay, so do we have any team who wants to volunteer and give it a try? There's no points for getting it right or wrong here, but just a try and to see if we have been able to grasp at least somewhat we were trying to speak about in the last 2 hours. Any volunteers? It can be a person or a group even. If you get into any kind of training, it needs a hands-on and some practical work that needs to be done along with it. Even an assessment. We are not doing an assessment here. We are just trying to apply what we learned in the last couple of hours. So please try to participate. Pritimoy, do we have anyone or else we move to the next section?
I think they move to the next section because
Okay,
nobody actually raised their hand. So
okay. Paromita, over to you.
Okay, so we talk about three use cases. Very famous, this one, which is the geo use case of the industry of India. This was one of the this was the first and the largest. So with so much of volume, you can understand with the India's population, 5G rollout. Now, what Geo has is a true 5G. That means we do not have any NSA. We have the 5G rollout. It has some deployments, SA plus NSA deployments in some areas, but very few. It had rapid metro and tier 2, tier 3 cities as well. Very interestingly, Geo has created their own 5G stack. However, there are associations with organizations like Ericsson and Nokia for very few part of the infrastructure. E2E platform play is the radio, the core, the OSS, BSS layer, automation layer. The usual ones are there in the Geo platform. They offer air fiber. Probably a lot of us use the Geo fiber at home. I'm on a Geo fiber at home. We have the enterprise as well, which is the Geo business. And then the consumer, and we talk about the challenges. For the consumer, we have the 5G mobile broadband. It also has devices which has coupled with 5G. And it has unlimited 5G data plan. Now, this is only initial. Why? The reason is, as I was mentioning earlier, monetization is a challenge. If the 5G, unlimited 5G kind of things remains in the market, the telecom service providers will not be able to sustain. So that will be going away very soon. And we should think about telecom as one of the utilities. For example, have any amount of ACs running and you still have to pay 500. It does not happen, right? So it should not happen again. And gaming and streaming use cases are also very well in the Geo. In the challenges part, since it is so much huge for the Geo, the network quality variability is there. We will find in some areas still Geo is not good, Airtel is much better, so that one is still there. Monetization, as probably I have been parroting this for many a times, monetization is a big challenge. And infrastructure is a cost here for Geo because most of the things are indigenous. If you see on the right hand side, I have tried to give an illustration of their network where with the transportation layer, now the UE that I was mentioning, which is the user equipment, comes down below. Then we have the transport layer, which brings all the smartphones, and actually UE is already covered here. UE, air fiber, all these brings the transport layer data to the transport layer. Transport layer will bring it to the 5G RAN first, then to the 5G core, and then it goes to the cloud ecosystem where multi-edge, multi-access edge cloud nodes are there, private 5G networks are there, enterprise solutions are there. The other use case that I have is from Europe. If you know, in Europe there is a bit of geopolitical challenges as well, where Europe has a very fragmented structure, and there are a lot of policies which are, or the governance which is there. So when US is going ahead with any kind, with a lot of implementation of the fast technologies, Europe is pacing it a bit down, and it is creating a lot of policies to protect itself. There is no right or wrong. This is what is happening in Europe. I'm taking a use case of Orange. Orange is one of the telecom service providers there. This is one of the Europe's largest telecom service provider, and it is present in 25 plus countries, which is beyond Europe as well. It has a very strong government ownership in many of the countries. I think Spain has one. It owns a big stake of Orange. Architectural landscape, it has 5G native cloud, 5G native, 5G and cloud native core architecture. The network slicing is already implemented. They have open RAN strategy and edge computing and cloud native automation. Orange provides industrial 5G use cases. They have the public safety networks and defense and sovereign clouds, which are the latest which is coming up. Again, in the challenges part, vendor politics is there. So while some of the CTOs of Europe are saying that they will not be implementing 5G unless it is like regulated, it is mandated, there are some of the other organizations, other TSPs, which are going ahead and implementing it with a lot of politics, vendor politics there, because Huawei is already banned in Europe. So they have to have Huawei and ZTE. I think only Huawei is banned in Europe. They have to depend heavily on Ericsson and Nokia. With the US-China equation, there are different kinds of influences there as well. Since Europe has very different culture across different parts of the Europe, there is fragmentation. And also it is especially for Orange, there is a problem of the capital intensity and as well as the low ARPU. Cybersecurity pressure is also coming from the governance bodies. Now in Europe, not only with Orange, but many others are having merging and acquisitions. Mergers and acquisitions are happening. Very recently, Orange was merged to Mas Mobile. Earlier it was called, and now it is called Mas Orange, which is the center is in Spain. And Totem is an organization which spun off from Orange, which is taking care of the RAN business. The future, there will be full CN network, full cloud native networks. They'll have full 5G SAs, open RAN again, and the defense and sovereign telecom and AI native networks are on the cards. I'm just skimming through because of the time. Now, the other industry test case that I have is the Southeast Asia. Now, with the Southeast Asia, the geopolitical situation is a bit different. The policymakers change very often in Southeast Asia. So there is now technically their challenge is they have there is missing contiguous mid-band blocks. So these are separated, and because of which you will find there are a lot of challenges later on, which is mentioned out here. IOH, which is a merging of Indosat, Ooredoo, and Hutchison there, which is IOH structure there. This IOH has the 5G architecture of from AI native, cloud first, capex optimized 5G, as they call themselves, and it is not spectrum led but efficiency led. Why not spectrum led? Because they do not have a contiguous network. So it's like they are doing a bet on whatever they have negative in their part, and then making the other part, which is a positive way of looking into it. The RAN is a multi-band NSA first. It's the strategy because as I was mentioning a lot, that these are cost sensitive. So wherever there is non-standalone opportunity, they're implementing that first so that people will be experiencing 5G. And whenever the time comes, whenever the money comes, then the SA can be implemented. So the multi-band NSA is the first strategy for them. And obviously, there is a strategy vendor mix, because there is no problem with the Huawei like the European part. And it has virtualized PC, meaning packet core. They have containerized network functions, hyperscalers integrations. These are all very good. And the transport layer has microwave fiber hybrid transport. Edge architecture with multi-access edge computing is implemented there. We have at some parts, not everyone. And then some part of AI RAN core and OSS BSS is also claimed to be in IOH. The cloud strategy, they have the telco cloud stack. That means the cloud which is suitable for the telco implementation. So telco flavored cloud. They have the open API exposures, or the ones which is allowed by their policymakers at this point of time. The enterprise 5G network also has the private network, small ports, and Industry 4.0 integration, which is also going on in IOH. The future looks bright, where SA core expansion is expected. There will be AI-driven autonomous ops and edge fabric expansion. Southeast Asia is the fastest growing telco industry of the world, because they have a lot of legroom. So I think that's it with the industry examples. Very brief, very quickly, I know, but it's only 4 minutes that we have left.
I think while we speak a little about what we tried to cover today, which starts from the 1G to 5G journey, how it, in terms of the timelines, the changes in technology, and how and where we are today in terms of technology and industry trends. We spoke a little deeper into 5G and what we are expecting in 6G when we move into 2030. We spoke about, or we learned about IoT and smart cities. So both of these are very extensive subjects, but at least in India, how IoT and smart cities can play a significant role in terms of changing our lives, with 5G creating the foundation for utilities, mobility, safety, and services. And we also spoke a little about beyond 5G, which is Wi-Fi 6, Li-Fi, and satellite as complementary connectivity. There is a operating model slide, but I think we will take a pause here, and we will spend the rest of the time for questions, if you have any one of them. Open to the floor.
Yeah, if you have a question, just raise your hand. I think we have to conclude the session. If you have no question, give 1 minute. So raise your hand. If not, then we conclude the session.
I have one question, and if none of you have one. At the beginning of the session, I wanted to ask, what is the objective and what would you want to understand from this session? There was no answer. Now we are at the end of the session. I would want to understand, what did you learn? And I'm ready to accept and understand we were too fast, or we were too difficult to understand, or we were completely away from what you expected. But at least someone speaking something would be encouraging for all of us.
Yeah, Rajiv Kumar
So, Prit-
Thakur asked the question. Yeah. Why internet in India cheaper than other countries, global average?
Shall I take it?
yeah, please.
Uh, Very quickly, ARPU, the average revenue per user in India, be it internet, be it telephonic data, it is less in India because if it is more, then people will not get business. This is pure economics and financial. And then we are already seeing a huge jump in the telephony fees that we are paying in last couple of years, and probably we'll see more. Or else, as I was mentioning, it is not sustainable. The other parts of the world probably has already understood that and taken the steps. So India is cheaper.
Sir, I can sum up whatever you have taught today.
Please.
Okay,
Yes,
so
yes.
yeah, so I think what you intended to teach us and what we learned today was first is what is 5G. So it is when it was introduced in India, what are the speeds, what are the features, then the kind of IoT support that is possible through 5G in terms of sensors, devices, etc. And then you also covered Wi-Fi, the type of Wi-Fi, and some other, I think, advanced versions of it, Li-Fi, and there was one more. And then you covered smart cities, made us understand what all facilities can be there in a smart city, what all does it entail, and what is India doing about it, what are the challenges, and then you also briefly touched upon the next technology, that is 6G, which you said it will be introduced by 2030 or so. So all of that we learned, and I think it was a very insightful session. Thank you.
Oh, one question. Excuse me, sir. Hello.
Sir.
Okay.
Yeah.
I would love to, is that slides are available to us?
Yes, we
So
can share the
slides.
slides with you. We'll
Okay,
share
then
the
please.
slides with Pritimoy, and he will share it back with all of you.
Okay. Thank you, sir.
Yeah, Tathagato raises his hand. Yeah, Tathagato, please. Tathagato Raichaudhary, you raise your hand. So if you have a question, then ask.
By mistake might be.
Maybe. So now it's the time to conclude the session. Yeah. So today's session on 5G and advanced network technologies has been truly insightful and enriching. On behalf of the organizing team of MAKAUT, I extend my sincere gratitude to our distinguished speakers, both Madam and Abhijit, for sharing this valuable knowledge, practical insights, and the future perspective on this rapidly evolving field. Actually, the discussion has helped us to understand how the 5G is not merely an upgrade in communication speed, but transformative technology that is reshaping the industries, especially enabling the smart infrastructure, supporting the Internet of Things, IoT, and laying the foundation for the next generation digital ecosystem. Such interaction actually bridge the gap between the academia industry and help us remain aligned with the technological advancement shaping our future. I would like to thank all the participants for their active presence and engagement throughout the session. But more support, more response actually required from their end. And day after tomorrow, we will again meet at the same time, that means 21st February, and the session will be on the cyber security. So thank you all of you and good night. So it is time now to conclude the session. Thank you.
Thank you.
Thank you. Bye-bye.
Thank you.